This is Dr. Holt. This video is on working with basic trigonometry. The objective of this video is to do an introduction to some of the basic trig functions such as cosines, sine, tangent. I'll touch a little bit about secants, cosecants, and cotangents. I will also talk about the three basic triangles and the ratios that you should know, as well as I will apply the rules of trigonometry and solve 2 to 3 problems. What I want to do first is we're going to draw ourselves a simple triangle, and it's going to be a right triangle. Okay, my picture's not the prettiest thing in the world. There'll be my right triangle here. I'm going to label this angle right here as theta. This angle right here, I'm going to call it beta. I'm going to give each side a variable, A, B, and C. Now, one thing we want to do is establish where the hypotenuse is. If you ever struggle with this, it's always directly across from the right angle. So this will be your hypotenuse side, all cases. Now, by definition, the cosine of an angle, I'm just going to put angle, because any angle is always going to be the adjacent side divided by the hypotenuse. And the sine of any angle is going to equal to the opposite over the hypotenuse. Okay, and then the tangent of an angle is equal to the opposite over the adjacent. Okay, sometimes you're going to also be working with secants, cosecants, and cotangents. An easy way to remember these is, because people get confused and they think, oh, when I have the cosine, it's 1 over the cosine, the secant, or the cosecant. A good way to remember that is the C's and C's never go together, but the C and S's will always go together. So I'm going to do this in a different color. Let's do this in a blue. So the secant of an angle is always equal to 1 over the cosine of the angle, which is always going to equal to the hypotenuse divided by the adjacent side. The cosecant of an angle is always equal to 1 over the sine of the angle, which is always equal to the hypotenuse divided by the opposite. And the other one is the cotangent of the angle. Oops, I put cos. Let me fix that real quick. Sorry about that. The cotangent of the angle is going to equal to 1 over the tangent of the angle, which is always equal to the adjacent over the opposite. Now, you do notice, and I'll do this in a different color, what I meant by the C and S's go together. The C and S go together in that you have adjacent over hypotenuse, now you have a hypotenuse over adjacent. The sine here will go with the cosecant, and the tangent and cotangent also go together. Alright, let's move on and let's define which each of these is going to be. If we come to the picture here and we have theta here, we want to find the cosine. This right here is the adjacent side. It's adjacent to the angle, and this is the hypotenuse. This is the opposite. B is opposite of theta. So we could say that the cosine of theta is equal to adjacent over hypotenuse, which is equal to A over C. We can also say that the sine of theta is equal to opposite over hypotenuse, which is equal to B over C. And we say that the tangent of theta is equal to opposite over adjacent. That's B over A. Now, one thing I want you to pay attention to in this, again, moving ahead, but this shows up also on the SAT, is let's do beta for a second. Excuse me, do beta for a second. Let's look at the cosine of beta. Now, beta, again, this is adjacent, so it's going to be B over C. Adjacent over hypotenuse. What's the sine of beta? The sine of beta is A over C. What's the cotangent of beta? I'll put these parentheses too. So cotangent. Don't want to do cotangent, I want to do tangent. Let's change that real quick. Put this down as tangent. What's the tangent of beta? Well, beta is going to be opposite, so it's opposite over adjacent, so it'll be A over B. Now, here's something I want you to notice. I'll do this in red. What is the cosine of beta equal to over here? Well, isn't the cosine here the same? And isn't the sine here the same? And the tangents are going to be in just flipping it. But a good thing to note is that we know in a triangle that all angles add up to be 180 degrees. Have a 90 here. So I know that theta plus beta plus 90 is 180. So I know that theta plus beta must equal to 90 degrees. So if this is the case, in all cases, then the cosine of the theta will also equal to the sine of beta, and the sine of theta will also equal to cosine of beta. And this works with any angles where you have two angles as long as they add up to 90 degrees. So if you ever see a question of this, is what is the cosine of 10 degrees minus the sine of 80 degrees? These have to be the same because 10 plus 80 is 90. This will always be 0. This problem here does show up on tests like SAT, and it confuses students often, but again, these problems are very simple because as long as those two angles add up to be 90 degrees, the cosine of one will equal the sine of the other, and the sine of one will equal the cosine of the other one. It's just a good thing to know. Alright, so this is the basics of trigonometry. If I wanted to find, let's say, the secant, if the question is, what is the secant of theta? The easiest thing, I think, to find the secant of theta is to know the c and s's go together. If I'm looking for the secant of theta, I find the cosine, and so the secant of theta would just be c over a. If the question is, what's cosecant? Well, c and s's go together. I say, oh, the sine is b over c, so the cosecant must equal to c over b. And what is the cotangent? Well, the cotangent is 1 over tangent, or in this case, a over b. Alright, there are 3 basic triangles and the ratios you should know, and I'm going to write those down for you. And the first one is, again, the pictures do not necessarily represent as far as being a scale, but let's make this into 30 degrees. You got a right angle here. The ratios you should know with 30 degree, the adjacent side would be the square root of 3, that's 1, and that's 2. Now that does not mean that if I have any 30 degree angle that I'm always going to have this length. It just means the ratios are going to be this. So I could say that the cosine of 30 degrees, which is equal to adjacent over hypotenuse, is going to equal the square root of 3 over 2. And I know what is the sine of 30 degrees. Sine of 30 degrees is 1 over 2. And what is the tangent of 30 degrees. Again, opposite over adjacent. We write it this way, but again, we don't like the radical in the denominator, so multiply the both times square root of 3, and you get the square root of 3 over 3. So those are the ones you should know for the cosine for the 30 degrees. So these are common ratios here. Let's look at the other one, and we'll do the 60. Now we can apply kind of the rule I just talked about a little bit ago. As long as the two angles add up to be 90, that the cosine of one equals the sine of the other, and vice versa, and I'll prove it. So this ratio will be 1, the square root of 3, and 2. This is a 60 degree. Well, what is the cosine of 60 degrees? 60 degrees is 1 over 2. Again, notice these are the same. What is the sine of 60 degrees? Well, opposite over hypotenuse, square root of 3 over 2. Again, what do you know? These are the same. And then what is the tangent of 60 degrees? In this case, be the square root of 3, which is if we flip this exactly inverse of that. So again, there's the 30 degree and the 60 degree. I'll make this right angle, forgot to do that. These are the ratios we should know. And the fourth one I'll just do off to the side is the 45 degree angle. Again, if you've done the unit circle, you can validate each one of these true. The ratios to know, though, with a 45 is 1, 1, the square root of 2, where the hypotenuse is here. If we write those down, this is the 45 degree. So what do we know about this? The cosine of a 45 degree is adjacent over hypotenuse, 1 over the square root of 2. Again, we don't like the radical in the denominator, so we do this. And if you notice on the unit circle, if you've done that, this is the value you're going to get. Well, we know right now, looking at the sine, is the same thing, so we know that the sine of 45 degrees is equal to the square root of 2 over 2. And what is the tangent of 45 degrees? It's going to be opposite over adjacent, which is equal to 1. So these are the 3 basic triangles that we need to know. And now I'm going to show you how we can apply some of these rules, or some of these angles. So let's draw ourselves another triangle. Okay, I'll draw a right angle here. We'll make this to be 30 degrees here. I'm going to make my hypotenuse this time to be 5. I want to find this length. We'll call this x length. And I want to call this value y. Well, what we can do to find out what x and y are, by using trigonometry, we can say that x over 5 adjacent over hypotenuse, by definition, is equal to the cosine of 30 degrees. So can I say that x, bring the 5 up, is equal to 5 times the cosine of 30 degrees. But again, just a little bit ago, we said that the cosine of 30 is the square root of 3 over 2. So we know in this case, x is equal to 5 times the square root of 3 over 2. So x here would equal to 5 square root of 3 over 2. If I want to find y, I could say y over 5 is equal to the sine of 30 degrees. Y is equal to 5 times the sine of 30 degrees. But again, we know the sine of 30 is 1/2, so the answer would be 5 over 2. Alright, let's look at one where we don't know the hypotenuse. Let's draw one like this. Make this a right angle. Let's make this 60 degrees. And let's say we know this is 12 here. And let's make this time B, and we'll make this C. and I want to find out what these lengths are. Let's find b first. Well, we could say that b over 12, opposite divided by adjacent by definition, is equal to the tangent of 60 degrees. We use algebra, we solve for b. b is equal to 12 times the tangent of 60 degrees. But if we go back to our picture, what was the tangent of 60 degrees? Well, it's the square root of 3. So can we not just use the square root of 3 and say that b is equal to 12 times the square root of 3? Alright, to find c. C is maybe a little bit harder, but can we not go and say that 12 over c adjacent over hypotenuse is equal to the cosine of 60 degrees? Well, we know that 12 over c, and what do we know about the cosine of 60? Let's go back to our picture and look. Cosine of 60 is 1 over 2. So can't we say that 12 over c is equal to 1 over 2? So we use low algebra. Can we not say that c is equal to 12 divided by 1, 2, or c is equal to 24? Again, these would carry the same units as what the 12 is. Okay, there's some application. Let's talk about other things we probably should know when it comes to trigonometry. Some of their other angles that we should know, and these are the ones that are fairly simple, is that the cosine of 0 is always going to equal to 1, and the cosine of 180 degrees is equal to negative 1, and then to apply this, the sine of 0 is equal to 0, and the sine of 180 is equal to 0. Again, it goes back to the unit circle. Let's do the 90 and 270. We can say that the cosine of 90 degrees is equal to 0. Cosine of 270 degrees, let me put that on there, is equal to 0. The sine of 90 degrees is equal to 1, and the sine of 270 degrees is equal to negative 1. Okay, so these are the trig functions that we should know, and I'm only doing the cosines and sines. You could do the tangents, the secants, the cosecants, and the cotangents also if you chose to, but these are the values we should know for 0, 180, 90, and 270. Just one more thing I want you to know too, is that make sure you know that 2 pi radians is always equal to 360 degrees, which means that pi radians, we divide both sides by 2, pi radians is equal to 180 degrees. If you're doing 30 degrees, again, you can just do a little algebra here. 30 degrees is always equal to pi divided by 6. Terrible 6, pi over 6. 45 degrees is going to equal to pi over 4. And 60 degrees is equal to pi divided by 3. Anyway, this completes my video. This is just a very basic introduction to trig and how to apply it. I hope this was useful, and I wish you the best of luck as you apply these rules.